Here, we're going to go through the drainage basin activity that is in the PDF file that is provided to you. This is what the PDF file looks like. Now, when you begin, you'll need to download and open the AutoCAD drawing for practice and make sure that you have the recommended layers. This is what the AutoCAD drawing will look like. The layers that you need are listed in the PDF, and I've also listed them here for you. This will allow you to turn different layers on and off so it'll be easier to draw, see, and analyze different items on the drawing. You should make sure that all your layers are set up now. If you need to pause the video, please do so. It will also be advisable to make sure that the layers are arranged with different colors and or line types so you can tell the difference between them when they are all on the screen. This is another picture of what the drawing should look like when you open it. You should see curves that look like this with the appropriate contour labels. There may be distinction between certain contour levels. For example, every contour layer that is a multiple of 5 is a certain color and thicker, so it can be easily found. This is generally a good practice to follow when you're working on contour drawings. The first step you need to do is to change the current layer to channel CL, that's channel center line, so you can draw the center line. If you look at the figure, you should see the center line in a place where the contours come to a V shape. This signifies a sort of a valley that is a natural location for a stream to form. Use the polyline tool in AutoCAD to draw the center line of the channel. The next step is to change the current layer to channel DF to mark the direction of flow. DF stands for direction of flow. This will allow you to mark arrowheads on one layer so you can turn them off later to analyze the length of the line. You will mark the direction with the leaders or draw triangles to mark the direction. Keep in mind that the flow is going to go from a higher elevation to a lower elevation. You can see that I have 155 here. I've got 150, 145, 140, so on. It gets lower and lower. That is why the arrows point in the directions seen in the picture. You may also need to modify specifications if you use arrows. Now you should change your current layer to outlet so you can mark it with text as shown here in this picture. The next step is to change to watershed boundary so you can draw the boundary on either side of the watershed. This is the maximum width. You can see these lines here. This is the maximum width as the stream as the rain falls. This will allow a developer to see if the watershed will encroach on a property or a development that is going to be built. This is really important to do before a structure is built so you can predict if any major flooding issues will occur. These should also be drawn in V's or where they have a change of inflection there on the contour lines, just like the center line was drawn. So you can see that there's the boundary on one side, there's the boundary on the other. Now, this is where the layers you have will come in handy. You should turn off all layers except the watershed boundary and watershed hatch. While you're in watershed boundary, you should close the ends. You can see they're circled here. Close the ends of the watershed. This will allow you to hatch the watershed on the watershed hatch layer. At this point, you can turn on some of the layers to see what the watershed boundary will look like and the hatching will look like. The picture has the contours turned back on with a few other layers. The next step is to analyze the length of the watershed line. You may need to modify the units of the drawing to be able to do that. You can use the property palette or the distance command to get the length of that line. Specific instructions are on page 485 and 486. That's actually pages 6 and 7 in the PDF. And you can see that that's the length of the line that was given. The next step is to find the area. You can use the tools noted before to find the area. However, you may need to convert the number that's given. Okay? The scale factor you may need is 1 acre equals 43,560 square feet. You can see that this is given in square feet, so a conversion is needed. The very last step is to document the measurements of the hydrologic length and the watershed area. It would be professional to place a border and title block around your work as well. An example is shown in this picture.